Hello everyone and welcome back. Today we're going to be talking a little bit about R programming language. I'm going to introduce you to R Studio and how to get started in it, and it should be very simple for you. I'm going to take it slow and I'm going to explain each and every part that I think is relevant for beginning. So the first thing you need to know is how to install R. So you have to download and install it from this website right here. And then you have to download and install R Studio, which is basically the program in which we will be writing our code and then running it to see what it looks like. So making graphs and stuff like that. So this is the link for that, and then you have to run R Studio. So the first thing that happens when you run R Studio, I made a shortcut in this folder, but you don't have to do that. So let's just open R, and you're going to be greeted by a screen looking something like this. So don't worry, it just looks like a lot, but it's not. So first thing that you have to know right here is where your variables will be. So variables are going to be things that are going to hold numbers, for example, and they're going to be just written here so you know what you're working with, but it's not going to be as relevant as everything else for starting in R. So right here we have the broom, and you have to remember that because we're going to use that later. It basically means just clean the environment. It's going to work for every one of these. There's 4 of them actually. Right here, if you click, you're actually going to see another screen, and this is actually going to be our main screen. I don't know if this has already popped up to you, but you can just minimize it like this, and you can do the same for the other ones. So right here we have the plots and the file. You can actually look through your files right here, and we have our plots. This is going to be the main screen for the plots right here, and we're going to look at this the most. If you want to install packages, you have the packages right here. It is really easy to install them and update them. You have the help right here if you want. You can visit the website and stuff like that, see the documentation, and the viewer as well, which is not relevant for this right now. Okay, and right here we have the console and the terminal and the jobs. Now all you need to care about right now is the console, because that's where most of the things are going to happen. The terminal is basically your Windows terminal, and the jobs is basically jobs that are currently running. But we're going to use the console only for now. So right here, as you can see, it says R script. It is the language that you're using. So if this seems right with you, if this looks right with you, then we can get started. But I'm going to import my file first because I already have one. You can just rewrite everything as we go. I already have a file prepared for you. So I'm going to go File, Open File, and I'm going to find my file, which in this case is in this directory. And I'm just going to paste it right here. And there we go. Now I can actually click on it. It's .r. And if we load it in, there's my stuff. Now this is the code that you're going to write, and it's going to output here, and it's going to make graphs here. And the variables from the code, for example, this k is going to be here. Now let's explain what this k is. It basically is a variable. In this case, it's a vector, and it takes in numbers 1 and 1024. As you can tell, we have the comma right here which separates it, which means it's going to just take these 2 numbers. If we had something else, like for example here, that's going to mean from 1 to 1024. And this plot right here actually just makes a plot. So if you want to run a single line, you can actually use the run button right here. But if you want to run the whole program, you can use the source. Now, of course, I don't want to run the whole program, so I'm just going to run these 3 lines. Actually, I don't need this one because this is a comment. It doesn't do anything. It's just there as a hint to yourself. So let's run k. We have to first run k to make sure that the variable is in the environment, because if it isn't, we're not going to be able to make a plot of k because we don't know what to make a plot of. And then run plot, and as you can see right here, we have a plot. So this is our first plot in R, not a big deal. So then we have the 1 to 1024. Let's run that. So now we basically redefined k, as you can tell. It didn't make a new variable, it just used the old one and redefined it to something else. Also, if I print k right here, you can see the numbers from 1 to 1000. By the way, keep in mind that unlike other programming languages, in R, indexing starts with 1. Okay, so now let's plot the new k, but using hist. So we have plot and hist. It's a different type of plot. So let's run. And as you can tell, it looks like this. If we use plot from before and run it, you can see that we have a straight line, which means basically it just used a lot of dots that we created to make a line. As you know, we have from 1 to 1024. So if I write print k and then 77, it's going to print 77. But you can use this to go through your numbers because they're not always going to be in the row. So now right here we have all sorts of different things. We have the 0.5 and 1 in our variable, which is a vector. This c right here helps us understand what it is. And then we have the same thing right here. but we added the previous k to it, meaning it's going to look like that. And then we have the same thing where we added the previous k and where we added the c, the new c, and it's going to look something like this. And then we have the k is c of k and k. Now, of course, this is just a bit much because right now all you need to understand is this one and this one. So this isn't as important as the previous two for the beginners, but you can pretty much guess how they work. As you can tell, we're adding new data into this vector thing, and then we're adding into the variable. So we're just filling up the k variable, and in the end, it's going to look something like this. Then we're redefining k again, which is c, 0.5, and 1. And as I said, it's a vector, and you can actually see that if I print it out after doing all of these, you can actually see that k becomes the last thing, and that's how redefining works. So if I print k, it's actually going to print the last thing because we redefined it regardless of what this was. And if we print 1, we're going to actually get these 0.5. There we go. And if we print 3, we're actually going to get an error because we don't have 3 values, we have 1 and 2. So let's try to do that. And we got an NA. So this basically just means we got nothing. And then we have the ARR, which is just another variable. And in it, we're putting numbers from 1 to 250. And then we're making a plot of it. And then we're printing it out. As you can see right here, we have added the variables right here, and then we have made the plot from just running this. One thing that I wanted to mention is if you're going to run projects, which is basically just a more complicated thing than the single script, you're going to want to set the working directory, or maybe you want to do that in scripts as well, because it might not read it for you. So you just have to use the set wd and then your directory that you find in Windows. You can get the directory easily by going to the folder and just pressing right here. This is your directory. So right here we have the read my file. In case you want to read CSV files, for example, you have the read CSV option and then the name of the file. This is going to be very useful for you because if you want to use R for data analysis or something like that, you're going to need this. Then also we have the packages. If you want to install packages, you can install them here and then use them like this. Or you can actually go to packages right here and then install them by clicking on them. And then to use them, you actually have to always remember to put a library and then the name of the library. So in this case, it's read R. You have to keep in mind, this is just like importing modules in Python or importing libraries in programming languages. So for example, libraries are ggpubr for a more graphical display and the dplyr for grouping data. And then right here, we can make a histogram of a specific column. So I'm going to get to what that is later. So if you have a specific part of the graph and you want to make a histogram of just that, you can do that. And you can also use that to set up the X and Y axis as well. So now let's take a look at this data right here. If we go ahead and write data and then put these brackets right here and run that, we're actually going to get a new data set opened. And this is just the R's default data set that you can use. It is basically just different data sets that you can use for your purposes, and you can use whatever you want. So as you can see right here, you can see, for example, infertility after spontaneous and induced abortion. It's pretty random actually. There's a lot of stuff here. There's like chicken weight versus age of chickens on different diets. I don't know why. Okay, so it doesn't really matter. And then you have the view discoveries. So I picked the discoveries from the data. It's just the name of the data set. And we want to view it, and I press run. And now you can see right here what we have is the data. Now, sometimes depending on the data, it's not going to show the whole thing. So we would actually have to go and print the discoveries, because that's going to give us more data. And then when you print it right here, you're actually gonna see that it says time series, which we didn't see before. And this means it starts with 1860 and it ends with 1959. So we didn't see that before, but this is going to be crucial in determining what's going to be on the graph. And this is the data that we got. So discoveries right here is just basically going to be how many discoveries did we have in years, depending. So starting with 1860. So then we have the plot of discoveries. We can run that. And as you can tell, it automatically plotted the years as well. So that's a great thing that it does. Even though we just saw these numbers and the index numbers, it plotted the years automatically. So that's a great thing. And now let's put this into a variable so we can refer to it later easier. So you can just put the data sets into variables like this. And now we have it right here. And now we can use it for whatever we want in the future. Also, let's go on to the maths. So you can assign the values numbers or stuff like that. So in this case, I'm assigning the sum value with the number 7 and the other value with number 2. and you can actually just add them together. So if we run this, you can actually see print latest value 9. So that does work too. You can do math stuff. You can do cool statistic stuff. So if you remember from before, we put discovers in the new variable, and we can actually print the maximum from the new variable. So this will actually print the highest value, and then we'll print the lowest value, which is 0. As you remember from the data set, we actually go and take a look at it. We can actually see that the smallest is 0 and the biggest is 12. So let's get back to this. So we have the minimum and the maximum and the mean. So mean is basically average, and we have 3.1 considering all the data, which seems about right, especially because of all the zeros. And then we have the median right here, which is basically the central value, the one in the middle. So if we have 100 values, it's going to be the 50th one, which is 3, which happens to be true. And then we have the range. If we run the range, it's going to show us from the minimum to the highest, which is 0 to 12. And then we can just print it as well. So this is just all the values. By the way, if you have missing values in your data sets, now you are going to, if you're going to use R's datasets, you're most likely going to be fine. But if you're using someone else's datasets, it's going to be very useful for you to know this. If you're going to have missing values, you can use na.rm. You can just Google that if you want to know more about that. You're going to find that useful in the future. Now let's move on to this comment right here. So it basically says that you can actually use the datasets, some data with some data, and you can use the, for example, exam A and exam B, which is going to be like multiple columns and rows in your data set, and you want to use just specific ones, and you can use a $sign and the name of the column. And you can use main right here to set the main title, and you can use the xlab to set the x-axis name, and you can use the ylab to set the y-axis name. I hope I'm saying this right. I don't know if axis is the real word for this. Anyways, so let's see the examples from the documentation. If we plot the discoveries with ylab important discoveries and last equals 1. I'm going to show you what that is later. We're going to get this, and now it says important discoveries and time. You can also set this using xlab to be years, for example. Just write the label years. So this basically just sets the label. The last one is the way your labels will be set up. So this means if we change this to 2, we're going to get a little nicer view, as you can tell right here. But if we do change it to 3, we're going to get a little bit of a mess because this goes to 0, 4, and 8. So I'm going to leave it at 2 because it looks nicer. By the way, at this point, we have too much stuff right here running and we have too many graphs. So I actually want to clear out the whole memory thing, and I actually want to run this right here. And we're going to delete all the variables from the environment and all the plots and all the stuff from the console. If I run this, it will work, but not because we have them in the environment, but because discoveries is actually the R's dataset. So if we had our own variables that we defined from before, for example, the K variable, as you remember, and we ran something including K, it will actually drop an error. Now we can also put the title main discoveries from 1860 to 1959. And if we put this, we're actually going to get a title, but it does look kind of weird. So we can change the size using the cex.main and then the size you want in numbers. So if I copy this and put it right here and put it to 2, for example, and I run it, it's going to look like this. Now don't worry, this has to happen. All we have to do is just clear it. And then obviously it's too big, so let's run it with 1. So as you can see, we haven't called the plot, we have to call it again. That's what I was talking about. The variable wasn't there, and then now we press run, and there you have it. Now it looks better. And you can also resize this to whatever you want, so 0.5, and run this, and then run this again. It's actually going to be smaller. This specific error happened because we're using the R's dataset and we didn't put it into variable. So as I said, if we put it into variable and it wasn't here, we're gonna give us an error. But if we called it once and it was here, and then we deleted the graph, we'll be able to call it from here because it's already there. So in the global environment. So now let's take a look at something else. Age measures from 10 to 60. And let's run this to get the variable in. And then we have the explanation of how to do this. We have the seq from and to, and then by 2, for example. So in this case, age measure 2 is going to be from 10 to 60 by 2, meaning this is going to be 10, 12, and stuff like that. As you can see right here, 10, 12, 14, 16. And we can print them out just to show you how this looks. 10, 12, 14, 16, and up to 60. And then right here, 10, 11, 12, 13, 14, 15. So this is all cool. Now let's get to plotting some stuff, and let's run this right here. So if you're in the first command, we're going to view the dataset women. So one thing I'm going to tell you right now is I'm not sure if this is centimeters and kilograms, but it seems to me that this is mixed up. I think that the height is how tall are you, and in this case, it doesn't seem to be the case. But if they are centimeters, I'm just gonna switch them up on the graph. I don't even know, maybe it's like American way of measuring, I don't know, pounds and feet. So To plot right here, we have the woman and height. We're going to use that as our x-axis. We're going to use that as our first input, and as our second, we're going to use weight. And we have the main, which is going to be our title. And then we have the xlab, which is going to be weight. As you can tell, this is the xlab and this is the xlab, and they don't match. This is why I flipped them over, because I think that it is the case that this is the centimeters and this is the kilograms. And then we have the ylab height and then weight. Now, of course, as I said, you can use a different data set, and then in this case, as I said, I flipped it over, but don't get scared about that. It's not a big deal. And we have the last two again because it looks better. And then we have the CEX main defined right here, so we don't have to make a separate title thing just like we did right here. So now let's run this line right here. As you can tell, it goes into the second line as well, but we can just run it. And it ran the whole thing, and now it looks nice. Look at these dots. So we can actually see the weight of people in this group, and it goes from 58 to 72. If we take a look right here, and it says 58 to 72. And it goes right here from 115, which seems to be a little less from 120, right? And then this is why it looks like this. And then up to 164, which seems to be here. So everything seems fine. And you can also make a histogram of it or whatever you want, like a bar plot or stuff like that. But that's pretty much it that I'm going to show you right now. I think this video is pretty long for the beginning. And there it is. That's all. Thank you so much for watching, and have a nice day.